In this question, we're given a Lewis structure of NCO-, and we're asked to assign formal charges to each atom in the student's Lewis structure. So I want to show you two different ways of calculating formal charge. So formal charge, mathematically, is equal to valence electrons minus half the bonding electrons minus the lone electrons, or the individual electrons of a lone pair. So this would count as 1, 2, 3, 4 lone electrons for nitrogen. This is mathematically how you can calculate formal charge. This will work. However, we can do this math logically, and in my opinion, doing this math logically is much easier. So let's look at an example for this, just this nitrogen, and then we'll do the other two logically. So nitrogen has 5 valence electrons. So for nitrogen, the formal charge is 5 minus half the bonding electrons. There's 2, 4 bonding electrons, so half of 4, which of course is 2, minus the lone electrons, 1, 2, 3, 4, minus 4. So this is 5 minus 2 minus 4, which is -1, which makes the formal charge on this nitrogen minus, which can be indicated this way, or you could just put a -1 here in the box to actually answer this question. However, let's look at it logically. Nitrogen likes to have 5 valence electrons. This has how many? Well, in these bonds, there's 2 electrons. But in any individual bond, 1 electron belongs to nitrogen and 1 electron belongs to carbon. So we can count the bonds as 1 because 1 electron belongs to each atom. So for nitrogen we count it as 1, and for carbon, when we calculate its formal charge, we count it as 1. So count the dashes as 1. Count the lone electrons as each dot is 1. So this nitrogen wants to have 5 electrons around it. It has 1, 2, 3, 4, 5, 6. If something has an extra electron, it has a -1 charge. Let's look at it for carbon. Carbon's in 4a, so it wants to have 4 electrons around it, 4 valence electrons. How many does this carbon have? 1, 2, 3, 4. This carbon has 4 electrons around it. Therefore, it wants to have 4. It has 4. It's neutral. It has a charge of 0. You could get this the same way using this formula. It would be 4 minus half of 2, 4, 6, 8. So 4 minus 4 has no lone pairs, so minus 0, which would equal 0. This formula, in my opinion, is kind of the long way of doing it. And if you think about it logically and you practice, I think you'll be able to do it much quicker, which will help you a lot if you take organic chemistry. Next, we have oxygen. Oxygen has 1, 2, 3, 4, 5, 6 electrons around it, this particular oxygen. Oxygen's in 6a, so it wants to have 6 electrons around it. It wants 6, it has 1, 2, 3, 4, 5, 6. Remember, count the dashes as 1, count the dots as 1. Wants 6, has 6, it's neutral. So, we have now figured out the formal charge on each of the atoms on this proposed Lewis structure. This can't be ideal, because we have a negative formal charge on a less electronegative atom. But in this case, it doesn't ask us to solve whether this is the ideal Lewis structure. It simply wants the formal charges. Note that formal charges are often written on atoms. So in this case, I wrote the negative on the nitrogen. And since these are 0, we don't write anything.